Hey, I am Dominic Tourneau. I am founder and CEO of Resonate. And today we will talk about race conditions. At Resonate, we are pioneering a novel approach to distributed computing. Distributed async await. Distributed async await is an extension of async await that goes beyond the boundaries of a single process and makes distributed computing a first-class citizen. Transitioning from synchronous to asynchronous programming introduces concurrency. And concurrency introduces the possibility of a race condition. Frequently, race conditions are not formally defined, but introduced in terms of an example. The most popular example I am aware of is two threads reading from and writing to a global variable. Here, two threads add 1 to a global variable x. First, in order to illustrate the race condition, we need to expand the code to accurately reflect its execution semantics. This highlights that reading from x, increasing its value, and then writing to x are indeed separate steps. By visually indicating the execution order, we demonstrate that a trace may lead to an atomicity violation, a loss update. Now, while this is certainly an example of a race condition, it is not a definition of a race condition. So now, we will build a minimal computational model to provide a definition. A system consists of processes. A process consists of a sequence of steps. The concurrent composition of two processes is the set of all possible interleavings of their steps. A system contains a race condition if the concurrent composition of its processes, that is, the set of all possible interleavings, contains at least one interleaving that is considered incorrect. However, now there is still the question of what do we consider correct and what do we consider incorrect? And there is no definite answer to this question. What we consider correct and what we consider incorrect is entirely up to us. Correctness criteria are application specific. The most common notion of correctness is the equivalence of a concurrent execution to some sequential execution. And, as you may have noticed, this is the same correctness criteria that is known as serializability in the world of transaction processing. Now, to circle back to our initial example of two threads accessing a global variable, here we are looking at a specific type of race condition, a data race. The definition of data race varies by author. However, a common theme is that multiple processes access a shared resource, like a global variable, and at least one access is a modification, like a write. To summarize, a system contains a race condition if the concurrent composition of two or more of its processes contains at least one interleaving that is considered incorrect according to our correctness predicate. Thanks for watching.